Okay, so if you never watched my previous video, go watch it. There was the production function and equations. Now we're going to do the Cobb Douglas production function. So as I said before when I ended my video, both those are different. Production function versus Cobb Douglas, it's different. It's very different. It's absolutely different. This equation right now, I'm going to tell you what's it for, how we use it, and why it's so important. So, what do all these variables mean? So let me write it down. Yeah, let me write it down, right? So we got y is equals to a k, and they're the first spelling pronunciation error in my videos of 2025. This is kita. I don't know how to pronounce it. It's kita. So kita, tita, tita. I don't care really. What I do care about is economics right now. And then the times. So times you represent it as a dot, n, and then to the power. So all these are powers. Yeah? 1 minus kita. So kita is there. Okay, so yeah. Okay, so this is the equation. Now, what this whole equation means, before I show you what it means, let me show you what it actually represents. So, if you take this equation right here, alright, if you take this equation and if you plot it on a graph, it looks something like this. So, let me just draw my axis. Let's see. Come on. Where's the straight line? 1 second. Okay. Now, if I plot this graph, it looks something like this, right? Let's see. Now, we're going to be discussed just now why it's sloping like this and all, but right now, that's how the graph will look like. Now, as I said, right, this graph represents output growth. This capital Y is this. Capital Y is basically like GDP. Its GDP is growth, but the true definition is output growth, right? Output growth, the whole growth of the economy. Now, obviously, the growth of the economy will depend about various factors. So sometimes over here will be capital, sometimes here will be labor, most likely capital, right? But it really doesn't matter actually what's here. Fun fact, it doesn't matter what's in here. Whatever is written here, it really doesn't matter because all you want to know is the growth, the Y, the output growth. Now, this equation over here, you'll basically use it to. Okay, so I'll tell you how tests work, right? As I said before, in economics, most likely all these things over here that we do will be MCQ. So they're going to give you variables. They're going to say A is 20, which is technology, K, which is capital, is 15. Then they'll say N, which is labor, will be 7. And then they'll say kita is 7. Then work out Y. Or they'll give you Y, give you A, give you K, theta, but won't give you, and then you have to solve. So basically, you're going to be solving for some variable. So knowing each variable is crucial, right? Now, why we know it's output growth. So wait 1 second. Okay, so we already covered Y. I told you Y stands for output growth. So output growth. So output growth is equals to Y. Capital Y. Now what is A? A is technology. So A, they sometimes say technology, or they sometimes say total factor of productivity rate. Total productivity of factors, yeah. Anytime you see technology, productivity, they're talking about A. So if they say technology increased, they're talking about A. To say productivity increased, is they're talking about A. Productivity of technology increase is A. So whenever you see technology, they say also total productivity. So whenever you see productivity, technology, just think about A, I'm telling you. So total productivity, sometimes they call it. Which makes sense, right? Technology is the productivity, total productivity. And then what is K? K is capital, right? So all your machines in the business and whatever. And then N is labor, so the amount of workers you have. And then theta. Now theta is very important here, right? Theta tells you the share. K to the theta, that theta tells you the share of the capital, and then the L theta, the N theta tells you the share of the labor. Now what it means, huh? Okay. So if you never watched my previous video, that is why it's important to watch it, right? I told you we took an example of a pizza, right? We got a pizza here. Different things come from to make a pizza. You got your sauce, you got your flour, you got your eggs. Wait, do you put eggs in pizza? Okay, let's assume we do. There's three ingredients that goes into pizza. Similarly, ingredients go into GDP, right? Things have to make out growth. Now, share. What share means? Share basically means, like example, k to the theta. Whatever the share of k is, that means k is contributing that much to y, output growth. I want you to think about this proportionally. I want you to think about it, okay? Okay, very easy, very easy example I'll give you, extremely easy. You got an assessment, right? You got an assessment. The assessment is 100% of your completion. So completing an entire group assessment is 100%, right? You got Tom over here who did 20%. You got what you got? You got Mr. You got ZZ over here, right? ZZ did 50%. And then you got Lee. Wait, why am I writing the name? Wait, Lee. If Lee did 50%, 20, that means 30%. Now, can you see all these three things make it 100%? This is the share of Lee. This is the share of ZZ. This is the share of Tom. So all these are shares that contribute to this total pizza, the total exam. Similarly, GDP. What comes out of GDP is capital and labor, which are your inputs, and this makes up a certain contribution to GDP. Labor makes a certain contribution. So if they tell you theta is 0.3, obviously if you look at K, okay, wait, it disappeared somewhere. Okay, wait, it disappeared. No, it didn't disappear somewhere. There we go. K is 0.3, then it'll be 8K 0.3 times N. 1 minus 0.3 is 0.7. That means 0.3 of capital, which is like 30%, contributed. The capital, you had 30% of capital that made the total GDP. Then you had 70% of labor that made the total GDP. 70 plus 30 is 100, or you can say 0.3 plus 0.7 is 1. So it makes sense. They two inputs make the total GDP. Now, I told you in my previous video, factors is A, K, and N. Inputs are only K and N. We're going to assume in the share thingy majingy that we're only working with inputs. Therefore, N and K only contributes to Y, not A. A, that is why, is over here in this side of the equation, right? Okay. So now, how do they ask you this in the equation? Sorry, in the exam. They'll tell you A is 20, they'll tell you K is 50, they'll tell you N is 7. Then they'll say theta is 20. Work out Y, and you have to work out Y. They'll give you Y, they'll give you A, they'll give you N. They'll tell you theta, and you have to work out K. So that's solve for X, right? That's maths right there. So that's how it'll work, right? So if you know the equation, you know how it works. Right, now let's go to the most important part here. We need to explain why the shape of this graph, right? Obviously, all these things will be converted to numbers, right? So your graph will be like Y. One second. Okay, so Y is equals to A, let's say it's 30 times capital, let's say is 2, and then theta, let's say 0.3 times N, let's say N is 7, labor is 7, and then theta, if theta is 0.3, obviously this is 1 minus whatever this was, so it'll be 0.7. So can you see how this and this makes up 1? So this means 0.3 of capital made up this GDP, total output growth. 0.7, which is this labor, it was made up of that growth, 0.7 of GDP. This is their contribution to Y. They both contributed to Y in that manner. So this now, if you draw it graphically, it looks something like this, right? Yes, it's an exponential graph because it's an exponential equation. Right. I want you to look at this graph extremely carefully. Can you see how when we go around here, it decreases, the rate decreases? Now, this graph is actually increasing. Rate increasing, decreasing versus actually increasing, decreasing is different. Rate increasing, rate decreasing. Rate means gradient. Okay, so what does gradient means? Gradient is the steepness. The rate is the steepness. The rate over here is steep. This gradient is probably high. Can you see if you put a car over here? If you put a car, it's gonna roll very, very quickly over here. The gradient is steep, right? If you put a car over here, the gradient is not steep. So can you see how the cars over here, this is steep, therefore the gradient over here is steep, gradient over here is high, the gradient over here is low. So technically the gradient is decreasing. You can see over here the hill is decreasing, so gradient is decreasing. But now we want to know if it's increasing or decreasing. The graph will obviously be increasing. I mean, the way you look at it is the graph is going higher. Also a tick shape, see, the graph goes higher in that shape. If the graph just keeps on going higher, it's increasing no matter what, right? This graph is increasing no matter what. It's just gonna stop increasing right around here, but it won't stop completely. It'll basically, if you look at an asymptote, you know how you get in maths, it goes close but never touch. Yeah, it basically is like that. So it's still increasing, but it slows down. The gradient slows down. It's like almost like it's increasing by 0.0001. So small. Now, why does this happen? What is it called? It's called diminishing marginal returns. Now, why had diminishing marginal returns happen? Okay. Very simple example to why this happens. Extremely simple. Let's go to our pizza business, right? You have one machine, but you only have one person, right? Now, let's assume scenario one. How many pizzas can this man make in this business in a day? So this is a whole business, pizza business in a day, right? You got one man, you got one machine. Scenario one, he's probably going to make how many pizzas? We'll give him benefit of the doubt. He's good at putting one machine pizza in, out making. We'll give him he can make 20 pizzas in a day. We give this man two machines, he's gonna probably make like double, like 40 pizzas, right? It makes sense. We give him three machines, he's gonna probably make like 50, right? But can you see how slowly it's decreasing? Here it increased by 20, here it increased by only 10. So it's increasing by a very small amount. It's getting smaller, these amounts. Now, the small amounts you get is why the graph is looking like this. See, it goes like this shape. It goes smaller. This all represent those numbers in between that what I showed you. Can you see how it goes smaller? Now, why is this so? You have to use logic over here, right? So now, where's my pizza man went? Come on now, pizza man. Ish. Wait, let me find my pizza man. Oh, yeah, that's a job. So why is the numbers increasing? Why is the difference decreasing as you add more machines? You only have one man. You're not increasing the amount of people. So if you keep increasing the machines, right? Keep increasing. This man is probably not going to even keep up. This man is probably not even going to use all the machines because he can't physically use 5 machines at the same time, right? It gets too much. You can put 6 machines, 7, 8, 9, 10. It doesn't mean he'll continue producing more pizzas. It doesn't mean he'll go 70, 100, 200 pizzas. It's impossible. You got one man who's operating 100 machines. Impossible. So as you go up, maybe 1 machine, 2 machine will be more than 1. You'll produce a lot of pizzas. But that's because he can handle 2 machines. That's because he can handle 3 machines. But as the machines go up, the number of machines you got in a business, he can't handle those machines. So there must be a stopping point where like 5 machines is the only amount of machines he can use. So that is why the graph goes like this. Because no more machines he can use, so there's no more pizzas that can be made more. Do you get what I'm saying? Diminishing marginal returns. That is why now in the future slides we will discuss that we can increase the population, we can increase the number of people, then we can increase the machines, make more pizzas. You see what I mean? So yes, that's what I'm trying to say, right? So that's diminishing marginal returns. Okay, so what is MPK and MPL now? MPK and MPL is a gradient. So it's basically these numbers, the steepness of the slope. So the steepness of the slope, these are all represented by this equation. So I'll tell you straight, the way they're gonna ask you this, you look at exam paper, test paper, whatever, they give you this MCQ always like this, how it's phrased, right? So listen, they will give you theta, right? They will say the share of, oh no, okay, would this just one point do it, right? They will tell you the share of capital is 0.2. Then they give you multiple choice and all that. Now the way you want to do it is this. If you got 0.2 and you only got one variable out of all, now you're only looking at this part of the equation, right? MPK is equal to theta y over k. That's the formula, right? Ignore this. Now theta y over k, you got theta over here. Okay, share of capital is what? Let's look at the equation. Yeah, look here. Capital share is just theta. So technically when they say share of capital is 0.2, they're talking about the share of capital is 0.2, which is that theta over here. If they said share of labor is 0.2, that means this whole 1 minus theta is 0.2. So you see what I mean? So you gotta be careful over here. So share of capital is 0.2, it makes sense. Capital is 0.2, what will be n? 0.7 there, right? But we don't need to know that now. All we need to know is theta is 0.2. So in the MCQ, there'll be like 2y over 2k, 1y over k, and you'll be like, how do I do this? Whatever you got, just put it in the equation. We got theta to be 0.2, so 0.2y over k. And then now in the MCQ, you'll find that you have no of this. But think about it, simplify it. 0.2, it's what? 0.2, it's, I'm trying to think. 1 second, let me get my calculator. Yeah, I know, I'm sorry, I'm not good at mental maths. Let's see what 0.2 is in a fraction. If you just put 0.2 in a calculator, you get 1.5. So another way of rewriting this equation is 1.5 times 2y over k. Am I making sense? Because, 0.2y over k. Yeah, because 0.2y times 1 is 0.2y over k. No, wait, sorry, I make mistakes. We're just going to ignore this. 1.1 over 5 is 0.2. So basically, this is 0.2 times 1 over k, same thing as that. And obviously, you simplify it more. Let's see, you simplify it more. You'll get y over 5k. And in the MCQ, you'll see y over 5k, so you take that as your complete option. option. And yeah, that's this section which I just explained now, the Cobb Douglas Production Function. And yeah, now we'll go through differentiations. Yo, hard ones.